All right, I got the thumbs up from the tech guy. So we're starting with our next talk for this afternoon. The next talk is gonna be from a guy who just told me that he came specifically from the Czech Republic to give this talk, and he's gonna tell you about how to plan hockey careers with Python. Yeah, here he is, Jaroslav.
So thank you very much for a nice introduction. Also, thank you for having me. As I said, Joyce, earlier before this talk, it's quite an honor to be standing here and having a talk on a conference organized by PyData and also PySport. So thank you very much again. Before I start, I think I would like to get know my audience a little bit. So let me ask you a few questions. So please, can you raise your hand if you follow ice hockey, please? Okay, so 2 people, 3. Can you raise your hand if you follow field hockey? And I think you will be raising it again, right? So yeah, we are in Netherlands, so I expected it. That's nice. And maybe third and last question is if you can raise your hand if you speak Python, please. Okay, I'm glad you I'm glad you did, because I have prepared a few slides with Python code, so I am happy that you will understand it. And the very first slide is with agenda. So at the very beginning, I would like to introduce myself a little bit, then I will introduce my company that I work for. After that, I would like to talk about a problem that young ice hockey players have during planning their careers. After that, I would like to suggest some theoretical solution for that problem, and I will show you how we solve that problem in the inference phase of our production. Okay, so a few words about me. Once again, my name is Jaroslav. Maybe you saw that my name was misspelled on the first slide, so this is the correct spelling. I came from Czech Republic, and I work as head of sports intelligence at a company called Great. Even though it is pronounced Great, it is like written with typo, but it's correct like spelling in here, right? So yeah, this is correct. And also I work as or I have a part-time job and work as a data analyst for ice hockey club Sparta Prague, which is like the oldest ice hockey club in the Czech Republic, and I would say it is also the most hated club in the Czech Republic. Do you have any club like in football in Netherlands that is the most hated? No? No Ajax? No PSV? No? Okay, okay. That's nice that you love each other. Okay, so but I don't represent Sparta Prague today. I represent a company that is called Great. As I said, sorry, I didn't say it. Great actually develops a mobile application, which we often say that it's LinkedIn for ice hockey players. The reason is that basically 2 groups of users are using this application. The first group of user is actually young ice hockey players from age, let's say 13 to 18, sometimes to 19, 20. And these players are creating their profile on the platform. They basically try to look good on the platform by connecting some performance statistics, by uploading some videos about them playing hockey, and by showing their skills. And on the other hand side, there are coaches and agents that basically are looking for new players either to their team or to their agencies. So these 2 group of users meet on the platform, and basically we are, let's say, a recruitment platform for the young ice hockey players. We have around 25,000 of those ice hockey players registered on the platform, and on the top of that there are also some family members, those agencies, and those coaches. Okay, but we didn't want it to be only a recruitment platform. We also wanted to provide some added value to our users. That's why we have introduced a premium section with some premium features, and one of the premium feature that helps in the development of those young ice hockey players is, for example, the development report, meaning that the family of the user can pay some money, they can send a video of the player playing hockey, and then the video is watched by some of our development specialists, and he basically creates a pretty detailed report with areas in which the player is good at, and also areas which basically need some room for improvement. But the main feature that I wanted to talk about today, and about which is this talk, is another premium feature, and that is called Career Path Planner. Basically, the problem that we saw before is that when the players are, let's say, 13, 14, 15, something like that, the decisions that they make in their career in that particular point of time has a huge effect on the future, right? And that's why it is important to make good decisions. And in the current settings, those players make decisions mainly, I don't know, based on opinions of parents and agents or the coaches. But all of this are only, as I said, some opinions or like very subjective experiences of those people. These are not things or decisions made based on data, just on experience. And we wanted to provide, let's say, another way by introducing some sort of feature that would be, let's say, data-driven or based on the data. So our goal was basically to create this screen where you can, in this particular example, see that our user is playing 15 U AAA League in this current season 25-26. 15 U AAA means that it is a league for 15-year-old kids. AAA, it is like a top-tier league in the US. And his goal is to get to NCAA, meaning University League in the US, in the next 3 seasons. And in this particular example, we would say to this user, if you want to get to that NCAA in next 3 seasons, from our point of view, the best way how to do it is to transfer to 16U AAA League next season, and the other season into NAHL, and then you should probably be able to get to NCAA. We also thought that providing one path only or one suggestion is not enough, so we wanted to provide some alternative paths. That's why you can see those steps, path 1, 2, 3 on the top. And also we thought that, or the other constraint for this task was that we thought that basically if our user wants to get on some, let's say, professional level or top league, he should also, look to his performance. That's why there is that bar with PPG target, meaning points per game, which basically shows him some comparison with players that either play in the league that he is playing in currently, or performance with people that played at the league in that age and manage to get to that NCAA league. So he can improve himself compared to the others based on some performance statistics. Okay, and now how can we solve it in theory, right? We thought that when I transfer this problem into some chart, I can say that on this y-axis, I have some seasons from 1 to 4, where 1 is the first season, and I have some leagues from A to E. in our internal database we have around, I don't know, 1,500 leagues, so this is just an example. But I'm saying on that example that if I am, or my user is playing the current, playing the league in the current season number 1, and he wants to get into League E in the next, let's say, 3 seasons, then he's got a couple of options how to get there, right? That's very basic idea. And I'm asking what is the best option how to get there. When we use that example from before, we can say that maybe some option is to stay in the 15U league for the next 2 seasons and then transfer directly to NCAA, to the University League, which from my point of view doesn't feel very right, correct? Because playing the next season with like 15 years old kid when you are 16 and the next season playing with 15-year-old kids when you are 17 doesn't probably like improve your skills, right? So it doesn't feel like very likely. The next option maybe is to transfer directly from when being 15, then transferring directly to the University League. Again, not very likely option because you would probably need to be very talented kid, or I don't even know if this is possible like policy-wise on those universities. So from my point of view, the most likely trajectory could be to improving himself, his performance every season, every year, also improving the competition and the level of the league each season until transferring to the University League. But how does it look when we look at the real data? This is Connor McDavid. I know that you don't follow ice hockey, so this is probably the best ice hockey player in the world. He plays Edmonton Oilers, which is like club in Canada. He's Canadian. And when we look at his career path, we can see that before he was drafted to NHL in year 2015, he played for 3 straight seasons in OHL. OHL is like Ontario Hockey League, which is a junior hockey league in Canada, one of the best junior hockey league in the world. And we can see that he managed to play for 3 straight seasons before transferring to NHL. You can of course argue that this is like I don't know, someone like Messi in hockey, so this probably is not very relevant. So we can look at another player, which is Jack Eichel. He was drafted as number 2 that particular season, and he actually did that career path that I thought that would be right. He actually transferred each season by season until and improving his competition and level of the league he played in until he was drafted into an NHL. So how can we find out which is the best way? What is the best suggestion for our users for their career paths to manage to get to a professional hockey or to professional level in the sport? We thought that what we can do is to basically take all those historical paths of the users that we have information about and put them on some pile, right? So we put Connor McDavid's path in there. We can put Jack Eichel's path in there. And we can put all the paths of all the players that we have information about. And when we have this pile of those career paths, then we can probably do some statistical analysis on that, right? For example, we can create some distribution out of it, and for example, find out the path that was taken by the most of the players in our data set. But when we do it in in a production setup or on a real data, when we want basically to find out the path from some starting point to some target, we found out that this is not very possible. And the main reason is the coverage, because when we have some user base in our application, we would cover or find the path for, let's say, 20% of our users. And the main reason behind that is that if you play hockey on the professional level, then you have, I don't know, maybe 5, 6, 7 leagues that you can play in. But the younger the kids are, the more options they've got. Meaning, and of course, on the professional level, only very few players play. That means that it's very hard task to find exact path with in the historical data set of historical players. So what we could do, or when we thought how to solve this issue, we thought that what we can do is that basically this chart pretty nicely looks like some network or graph, right? Graph where the nodes are represented by seasons or combinations of seasons and leagues, and the edges of this graph can be represented by number of players that took that particular step in their career path. So basically what we can do is to create some directed weighted graph and find out or apply some graph theory methods on that in order to find the path. In this particular case, for example, the shortest path. And actually this worked, and this is something that we like deployed into our production because it boosted the coverage and the results were reasonable. And now I would like to also, as I said, show you the Python code to have a look or to see that it was not very, let's say, very hard. Okay, so I wanted to prepare a code from an inference phase, as I said. So on the inference, or at the start of the inference phase, which is basically deployed as fast API REST API, we need to parse some data from our request. Our request is created by 3 information about our user. The first one is current age of the user, the second one is current league, and the third one is target league, meaning the league where the player wants to get to. So when I look at this example, I can see that our player has or is 15-year-old. He plays in Czech Republic U17 league, meaning that he's probably quite talented because he plays with older kids. And his goal is to get into an NHL, which is National Hockey League, the best league in the world. The next thing that I need to do is to basically get the data of the historical players and their career paths. To be honest, I'm a huge fan of DuckDB, so I use DuckDB everywhere I can. That's why I also used it here. And the historical data are like or contain the paths of historical players, as I said, where each row is represented by one player and his career path. As you can see, there are some basic information, and in the columns we have encoded the ages of the player and or of the players and the leagues that they played in. So that means that, for example, the first row represents some defender from Canada that is right-handed, and when he was 10-year-old, he played in Ontario League, and when he was age 20, he played NHL. What we can do next is that when constructing the directed graph, we are probably interested in only those players that were relevant for our user. That's why I am like filtering the data only for that purpose. As the first step, I am filtering only the players that had a similar start as my player had, meaning that I am only interested in players which age is the same as current age and which league is the same as current league of my user. In the next step, I am also, or this is the start, but I also need the second part of the directed graph, which is the destination. And that's why I am filtering the players with similar target. In here, I am basically filtering all the players which played in the target league after the age of the current age of my user. And in the next step, what I do is that I concatenate those two data sets, and I create this relevant data set of my similar players that are similar to my player that I want to get the prediction for. After that, I'm using Network X for constructing a directed graph, as I was talking about it previously. I am constructing a directed graph in particular because it is not possible to like transfer from age 15 to 14. There is some logical like relationship between those transfers. That's why I am using constructing the directed graph. I do it by basically looping over some pairs of those ages, and I construct the source node and destination node from those combinations of ages and the leagues the players played in. After that, I create, or from that, I create an edge. As I said, the edge is weighted by the number of players that actually took that step in their career path. And when I have the directed graph like this, then what I need to do also is that I need to like transform this weight into distance by simply computing a reciprocal value. And that's or the reason behind is that in the next step I need to or want to find that most usual path for my player using shortest or finding shortest path in that directed graph. So that is why this technical thing. And finding shortest path is more or less very simple using this code. At the start, at the beginning, I will define the starting node as again a combination of the age and the league where my player is at. Then I get the potential targets again, like those nodes with that target league. And by using some sort of very simple Python code, I find the shortest path in my directed graph. As you can see, I'm looping again over those potential targets and computing the distance for every path, meaning that even though I am returning only one shortest path in here in this particular example, what I can do is to save all those paths and their distances to some sort of data object, and then like sorting them from the shortest to biggest, and provide those alternative paths I was talking about before. So I think that's it. Let me summarize it a little bit. Today during this talk I was talking I started with introducing great mobile application, which is application for young ice hockey players. One of the premium feature of this application is Career Path Planner, which we constructed by analyzing historical career paths of historical players. And we construct these career path suggestions by creating directed graph in the inference phase of our model. And we computing the shortest path in that directed graph and returning that suggestion in this screen. So thanks a lot for your attention. That is everything. If you liked my talk and would like to follow me or check the slides again, feel free to scan this QR code, which is not visible. So yeah, thank you very much.
Thank you. Well, there is the QR code now, so you can still scan it. Thank you very much for your talk.
Thank you.
We do have also some time for questions left. So are there any questions from the audience? Yes?
Thanks, Jaroslav. Very nice talk. And what my question is basically, you model like the success and the goal of like a hockey player as like reaching NHL or the highest possible league, but wouldn't make more sense to like having consecutive seasons in that league and assessing that as like the success, and so like modeling not arriving to the league but like staying in the leagues for a certain amount of seasons?
Yeah, this is also possible. As I said, we are trying to model or to suggest the career path for the user to like get into some target league. In this particular case, the target league is NCAA, and we think that he will reach it 28-29 season. But the way he gets there is on the model. So as you said or asked if it's possible that the player can stay in some league for more seasons, it's definitely possible, because if this option or these transfers basically are in our historical data of our historical users, then it will be shown in the model and it can be suggested by the model.
Thank you.
No worries.
Thanks for the talk. I just have one short question. Do you think that adding years of practice and maybe the league would add as a great, I don't know, predictor for future success?
Yeah, that's a really good question. I didn't talk about it, but adding some more, let's say, features for the player itself can definitely be valuable for the model and for the prediction. We have played around with some of them. I didn't describe that because I didn't want to get into that detail, but we use it as well, and it helps. Yeah, so I agree with that point.
Yes, thanks a lot for your talk. Really interesting. I was wondering if you can give us a little bit more information about the data, and especially how you handled selection and survival bias in the data with this kind of analysis.
So we get data from several sources. I think that survival bias is a really good point that we should consider as well, because the league's settings changes every year. For example, this season they changed like age categories in Switzerland. So from U18 we've got U19 and so on and so forth. So that's a really good point. However, to be honest, we are still a startup, and this is not the thing that we are like dealing with right now. We have some bigger things to do. So we are happy with this solution right now, and when we've got time and hopefully some more money, then we will start figuring these things. So
Thank you.
yeah, no worries.
Okay, are there any more questions from the audience? Oh, all the way in the back. You can.
Who is it?
Have you thought about adding like physical features to it and to like help with problems with relative age effect? And could your model also help like NHL teams to prevent burning their prospects when they move them to the NHL too early?
I'm sorry, I don't know if I catch the second part, but for the first part, yes, as I said before, we are also considering some other physical features of the players, and it improves like the predictions of the model.
Any more questions?
Yeah, I'll just meet you halfway. Thank you very much for the interesting presentation and coming
Thank
here
you.
all the way from the Czech Republic. I think with that, I also want to offer you one of the PyData mugs so you
Thank
can
you
take
very
it
much.
home. Yeah, and thank you very much for this presentation. And we'll be back shortly with the next speaker again. Thank you.